Hello everyone, I am Admile N.S. working as an assistant professor in SVERI's College of Engineering, Pandharpur. Today we are going to study the analog and digital integrated circuits. So in analog and digital integrated circuits, we have to study the 6th unit, that is a combinational logic circuits. So in combinational logic circuit, we have to study the representation of K-map. Then we have to study the concept of multiplexer, demultiplexer, adder. So in adder also we have to study the half adder and full adder. So let's start with the content of this unit. So first we need to understand the two basic terms, that is a mean term and max term. So for mean term, the mean term is the product of all input variables and the max term is the sum of all input variables. So the mean term can be always represented with the help of complement of 0 and the max term can be always represented with the help of complement of 1. So let's understand these two definitions with the help of truth table. So here the two input variables, that is A and B, and output as a Y. So here we can consider the truth table of XOR gate. We can consider the truth table of any gate. So how to represent this truth table in terms of mean term and max term? So to represent the mean term and max term, we have to always consider the input variables, that is A and B. So as per the definition of mean term, we have to take the complement of input variables, and as per the definition of max term, we have to take the sum of input variables. So for mean term we can take the complement of 0 and for max term we can take the complement of 1. So here we can represent the mean term as A bar B bar and the max term as A plus B. So for mean term we have to take the complement of 0 and for max term we have to take the complement of 1. So the next two forms, that is a sum of product and product of sum. So to represent the sum of product and product of sum, again we can consider the same truth table. So to represent the sum of product and product of sum, we have to consider the output column. So in order to represent the SOP form, we have to consider ones in the output column, and for POS form we have to consider zeros in the output column. So with the help of this we can represent the sum of product and product of sum. So for sum of product we can take the sum of product terms, and for product of sum we can take the product of sum terms. So for SOP form we have to consider output as a 1 and for POS form we have to consider output as a 0. So along with this we need to study what is a canonical form. So in some cases, that is in SOP form and POS form, all the input variables are not present. So for example, we can consider a simple example here, AB plus A bar BC. So in this case, in first term the C variable is missing. So to represent the thing we have to use the canonical form. So in canonical form all the input variables are present in each term. So how to represent the canonical form? So again we can consider the same truth table. So to represent the canonical SOP form and POS form, we have to represent the mean term with the help of small m and the max term with the help of capital M. So here we can represent the mean term as small m0, m1, m2 and m3, and the max term with the help of capital M0, M1, M2, M3. So again to represent the canonical form we have to consider the output equation. So for SOP form always we have to consider ones in the output, and for POS form we have to consider zeros in the output. So according to this we can represent the SOP form as Y is equal to summation of small m 1, 2, and for POS form pi capital M 0, 3. So in this way we can represent the canonical form. So again let us consider one more example. So in this example we can represent this truth table in terms of mean term max term, SOP form, POS form and canonical form. So here we can consider one random truth table. So how to represent the min term and max term? So as per the definition of min term, we have to take the complement of input variables. For min term we have to take the product of input variables, and for max term we have to consider the sum of input variables. So for min term we can take the complement of 0, and for max term we can take the complement of 1. So as per the definition of min term, we can represent the first term, it is a, B, C. So the three terms are zeros, so we can take the complement as A bar dot B bar dot C bar. And max term is the addition of input variables, it is A plus B plus C. So like this we can represent the all other terms. So for min term we can take the complement of 0, and for max term we can take the complement of 1, and the min term and max term can be represented from the input variables. For output equation, then for SOP form and POS form we have to consider the output column. So whatever the ones in the output column, so we can consider for SOP form, and whatever the zeros in the output column we can consider for the POS form. So in this way we can represent the SOP form and POS form. So again for canonical form we have to consider SOP form and POS form. So for canonical SOP we can always consider ones in the output column, and for POS we can consider zeros in the output column. So here summation of small m 2, 4, 6. So in the digit of 2, 4 and 6 ones are present, so we can represent the canonical SOP. What are the zeros? So in place of 0, 1, 3, 5 and 7, so we can represent for canonical POS. So the next thing is how to convert the SOP form into the standard SOP form. So let us take a simple example. So here we can consider example as AB plus BC plus AC. So the first thing is we have to identify the which variable is missing in a given equation. So in first term the C variable is missing, in second term A variable is missing, and in third term B variable is missing. So as the variable is identified, we have to take the we have to consider the missing variables. So how to consider the missing variables? So in order to consider the missing variables, we have to take the addition of the missing variable and its complement. So accordingly we can represent in first term C is missing, so we can take the C plus C bar. So in second A is missing, so we can take the A plus A bar. And in third term B is missing, so we can take the B plus B bar. So after that we have to simplify the equation. We have to simplify the equation. So after simplifying the equation, whatever the repeated terms, so we have to consider as a 1. So for example here ABC, the same term can be repeated, so we can consider at a only once. So like this we can convert the SOP form into the standard SOP form. So again we have to study how to convert the POS form into standard POS form. So similar to conversion of POS form, similar to the conversion of SOP form into the standard SOP form, we have to consider the conversion of POS form into the standard POS form. So again let us consider a simple example. So in this example we can take a first as A plus B into P plus C into A plus C. So the first thing we have to identify the missing variable. So in first term the C variable is missing, so in second term A variable is missing, and in third term B variable is missing. So in POS form we have to take the product of missing term and its complement. So Here we can represent the equation as a plus b plus c into c bar. So like this we can add the missing variable and its complement. So after this we have to again simplify the equation. After simplifying the equation, again we have to consider our rule. What are the repeated terms? So in this equation, a plus b plus c, again a plus b plus c. So these two terms can be repeated. So to represent the equation, we have to consider the terms as a 1. So as per the rule, a dot a is equal to a. And for SOP form, we have to consider a plus a is equal to a. So like this we can convert the standard SOP and standard POS form. For next lecture we can take the implementation of K-value.